Okay, guys, so AB, I know y'all did area between curves on the Friday before spring break. In BC, we haven't done this, so this will be a quick review of area between curves. So if you would, take these notes down. Bear with me as I try and get these videos a little smoother. When you're watching these videos, I think it's probably better that you watch them from your phone, if possible. You'll probably get better quality. You can try on your Chromebooks also, but so anyways, so the area between two curves, we're gonna go, the area is equal to the integral from A to B of your top curve minus your bottom curve. Okay? So if we have two curves that are like this, y equals. So say that's like y equals x squared plus 3, and this is some sort of line. Your top curve is going to be this one right here, and your bottom curve is going to be this one. Now the way we're going to get our limits is from the intersection points. Now if they don't intersect, we're going to have to be given some sort of intersection point. So this would be like your A, this would be your B, and we're going to be finding the shaded region like that. Now if it's something that has x equals, okay, so x equals, we're going to go from C to D of right curve minus left curve. And this is going to be in terms of y's. So this sort of graph is going to look like a sideways parabola and another line like that. Okay, where this would be C and this would be D. Okay, so this would be your right curve, the sideways parabola, and then the left curve would be the line. Now you'll have to have y limits on that type of example. So we'll do a few examples, and then we'll go through and do one with the calculator and having to use your Math 9, okay? So first example. So we're gonna find the area between the curves y is equal to 3 minus x squared and y is equal to a negative x plus 1. Okay, so our first step whenever we're doing this is we have to graph it. Okay, so when we go to graph this, just know a little bit about basic shapes of graphs and that sort of thing, parent functions. This parabola starts at 3 and it's going to be concave down. It's going to open downward because it's got a negative x squared term. So looks something like this. Now the graph doesn't have to be perfect. You just have to be able to, have the idea which one's on top and which one's on bottom. Okay, the line y is equal to a negative x plus 1 crosses at 1 and it has a negative 1 slope. It'll look something like that. And we're going to connect our dots. Okay, and we can see that our region is going to be this right here. Okay, our second step whenever we're doing area between curves is to find your intersection points. Okay, so our intersection points are found by setting the two functions equal to each other. So 3 minus x squared is equal to a negative x plus 1. Now, in order to solve anything with a squared, you have to set it equal to 0. Okay, so we're going to move everything over to one side, and we should get that. Now, we're going to factor that. So factors of -2 that add to a -1. So we should get x minus 2 and x plus 1. So our intersection points are x is equal to 2 and x is equal to -1. Okay? Now, from there, we're going to do the integral from -1 to 2 of your top curve minus bottom curve. So your top curve is going to be the parabola 3 minus x squared. And your bottom curve is going to be -x plus 1. We're going to distribute this negative out. So we get 3 minus x squared plus x minus 1. And then we're going to combine our like terms before we integrate. So we're going to integrate from -1 to 2. And when we combine our like terms, it should be -x squared plus x plus 2 dx. Okay, from there, we're going to integrate. So we got -1/3 x cubed plus 1/2 x squared plus 2x. We're going to go from a -1 to 2. We're going to plug in our top limit. And then we're going to plug in our bottom limit. Now make sure on this that you watch your signs, especially with the negatives. Okay, and when we do all that fancy junk in there, you should get 9/2. Okay, now this should be done without a calculator. So go back and double check this. So this would be 2 cubed is 8. So this is -8/3 plus 2 plus 4 minus 1/3 minus 1/2 and plus 2. And whenever we go through and do this, you have to get a common denominator. Okay, so that's why I get 9/2. Okay. And y'all can go back and rework that at your own pace. Okay. Next example problem. Okay, so we're going to find the area between two curves. Now this time we're going to do one that deals with sideways parabolas. So x is equal to 5 minus y squared. And let's do x is equal to y minus 1. Now, like I've said before, we don't have a lot of experience graphing this sort of thing. We don't deal with it a lot. So I'm going to make a t-chart to figure out what it looks like. Okay, so I'm going to pick good points. -2, -1, 0, 1, and 2. And I'm going to plug in for y. So -2 squared is 4, 5 minus 4 is 1. -1 squared is 1, 5 minus 1 is 4. And filling in the table, we should get these values. Okay? This becomes really easy to graph if we would just solve for y is equal to x plus 1. Just so we get an idea of what the graph looks like. We're going to be using this equation when we do our top curve, bottom curve, right curve, minus left curve stuff. But just for the idea of the graph, that's what we're going to use. Okay, so when we go to graph this. Okay, so it crosses at 5, 0, and we have the point 4, 1 and 4, -1. So it's a sideways parabola that looks something like that. Okay, in the line y is equal to x plus 1. So it crosses at 1, and it's going to go up 1 over 1. So something that looks like this. So eventually they will cross. So our second step when we do these types of questions is to find our intersection points. So our intersection points, we're going to set the two functions equal to each other. 5 minus y squared is equal to y minus 1. Move everything over, set equal to 0, so we can get our limits. So we should get y squared plus y plus 6 is equal to 0. Factors of 6 that give you positive 1. That's not right. Hold up. That should be a minus 6. Sorry. Y squared plus 6. Y squared plus y minus 6. So factors of negative 6 are y plus 3 and y minus 2. We set those equal to 0. So we get y is equal to negative 3 and y is equal to 2. So when we go to do our integration, this is the integral from negative 3 to 2 of your right curve minus left curve. Now we're doing right curve minus left curve because we have x equals, okay? So right curve minus left curve. So it's going to be 5 minus y squared minus y minus 1 dy. Okay, we're going to distribute our negative sign out before we integrate. Okay, so we should get 6 minus y squared minus y dy. From there, we're going to integrate. You get 6y minus 1/3 y cubed minus 1/2 y squared, negative 3 to 2. And we're going to plug in our top limit and bottom limit. So when we do that, we should get 6 times 2 minus 1/3 times 2 cubed minus 1/2 times 2 squared minus plug in the bottom limit. So you should get 6 times a negative 3 minus 1/3 times negative 3 cubed minus 1/2 negative 3 squared. Now, when we do all that, you should get 125 over 6. So once again, let's do that without a calculator and just double check it in the calculator using your Math 9. Now in the next problem, I'll actually show you how to use your calculator in your Math 9, just to review that. Okay, last example problem for today. Okay, so we're going to find the area. Find the area of the region bounded by f of x is equal to 3x cubed minus x squared minus 10x, and g of x is equal to negative x squared plus 2x. Now, most of the time when they're doing non-calculator stuff, you can pretty much figure out what the graph's going to look like. On a calculator section, it's sometimes a little more difficult to know what the graph looks like off the top of your head. So I would say this is a calculator question. So I'm going to graph the two functions. Okay, so we get that sort of business. Now, I'm going to just draw a little sketch on my paper just so you get a little bit better idea of what it looks like. So, sorry, I didn't draw it very good, so that should cross at 0. Okay, so what we can notice from this graph is that your intersection points are going to be here, here, and right here. Now, what's important to note that this is the cubic function, so this is f of x, and the upside down parabola is going to be g of x, okay? So what's interesting about this problem is it switches top curve and bottom curve. Okay, so our first step was to graph. Our second step is to find our intersection points. So we're going to go calc, intersect, and we're going to go over here, and it intersects at the point -2, -8. This should be the point. We're going to do it again, 0, 0. Okay, so this is point 0, 0. And this point over here is the point 2, 0. Okay, so when we go to set this up, we're going to have two separate integrals. Okay, so this is going to be the integral from -2 to 0 of your top curve minus bottom curve. So 3x cubed minus x squared minus 10x minus your bottom curve. Now I'm going to put this in the calculator. I'm going to do math 9. So math 9. Now my cubic function's in y1. So vars y1 minus y2 comma x comma -2 comma 0. Okay, we always put the bottom limit first and the top limit second. So you should get 12. Okay, now I'm going to repeat the process, but I'm going to use different limits. And my top curve and bottom curve switch for this region right here. The parabola's on top and the cubic function's on bottom. So -x squared plus 2x minus 3x cubed minus x squared minus 10x dx. Okay, so I'm going to repeat the process. We're going to do math 9, bars y1, y2 minus y1, comma x, comma 0, comma 2. So we get 12. Now the total area of this region, when you do it, comes out to be 24. Okay, so what I'm going to do is I'm going to post a file that has some worksheets with it, and it has some answers. That way you can check your answers. It's the Teacher from Kelly, her worksheets. I like it because it's a little bit different, and there are not too many problems on it. So I will also probably try and get you a hard copy of the whole entire packet. That way you have to work from it. But it will be worksheet 7.1, worksheet number 1, and worksheet number 2. Those will be due probably by the end of Tuesday of next week, because we won't start school until next Monday. So I will post these videos, and hopefully you'll watch them ahead of time and can get going on the work. That way it's not overwhelming and we won't lose too much. Appreciate it, and you'll have a good afternoon.